Thank you. I am very touched and flattered by this introduction. Thank you, Jean. Moving on with my presentation. So yes, my company is called Analytic Consulting. And I also, before I go to the other slides, I wanted also to mention that I'm a member of Alpha Zeta. Alpha Zeta is, on your screen you will see that Alpha Zeta is an end-to-end analytics company that works with its members on a freelance basis, and the representative of Alpha Zeta is here now. Anyway, okay, so but let me move on. And today we will be talking about a use case in predictive asset management. Now, obviously, as a consultant, I cannot, unfortunately, yet afford too much philanthropy the way Michael does, which I was very, very much impressed. So what we are doing is basically doing analytics for money, which doesn't sound good. Anyway, so what happens is all asset owning organizations, and that's a lot, that's utilities, that's transport, that's even banks, they have a lot of assets. So asset owning organizations, particularly in utilities industry, seek to practically optimize asset maintenance, asset cost, and prevention of failures. So obviously, if your electricity goes off, it's not very good for your electric company. Somebody gets very upset about it within the company. Now, for years, they used to use common sense to decide which, so when an asset will fail. And the conventional thinking was, basically it all depends on age. So basically there is this age curve, you know, in the beginning it's a bit, you know, too steep, so when you just install an asset, it misbehaves, then everything goes all right, then it goes up. And they tried, so, and they found themselves in a situation where they had to sell this idea to the regulators. The regulator in the industry basically tells them, look, if you want any funding, justify it. So they would go and say, oh, you know, they would show that curve, and that of course didn't work. So then they tried to go and buy an off-the-shelf solution. They bought one of the states bought one in the UK, and the Australian regulators of course said, well, excuse me, but in the state of, for example, Queensland, it's not exactly the same situation as in the UK. Different geography, different everything, so your off-the-shelf solution doesn't work. So then they started to look for alternative solutions, and that's when they understood that they need analytics. So, recent case study approaches that I was doing, so I am at liberty to tell about it because we had well, the client agreed to present it, that we presented at conferences, but I cannot, of course, give you the actual figures. That's confidential. Anyway, so a large Australian utilities company with a geographically diverse high-value asset portfolio needed an analytic solution. So what they wanted is, they had 12 years of data, and I will tell you more about that. But basically, they wanted to use that data to have 10 annual forecasts in the next 10 years. So a forecast for 2018, 2019, and so on. And what they wanted to have forecasted is how, for each asset, the cost, maintenance cost, unplanned cost, unplanned maintenance cost, probability of the failure, and duration of that failure. So, in other words, as you can see, they wanted for each asset groups, for each asset group, they had quite a lot of modeling, if you think about it. So you cannot, unfortunately, even go and do a hazard model, because they want an amount for each of the years. And so, also they wanted this solution for several groups of assets. So isolator, transformer, circuit breaker. So again, quite a lot of modeling. And also, because they were preparing this for the regulator, it had to be transparent, easy to understand, and easy to sell to the regulator, meaning that in the end they wanted a linear model. So it doesn't matter what you were doing in the beginning, in the end we had to come up with something that the regulator would understand. And the regulator would probably expect econometric methods which is linear. And also we needed to provide something that would be easy to implement in the organizational systems. So IT had to be happy, and that meant business rules. Nothing linear. Anyway, so let's see what we did. So we delivered the solution as they wanted. So basically, a usual sort of predictive analytics solution, and did what they wanted, which was easy to understand for business stakeholders and straightforward to deploy in the IT and linear. Okay, the data. The data was huge and not terribly tidy. So everything about the asset.
No.
Yes, normal, that's right. Asset technical characteristics, so everything about the asset, how old it is, where it is sitting, is it very far from the coast, is it close to the coast, all that. So then facility where it was, operational performance, and so on and so forth. So huge data, again, real world data, nothing unusual. This is when it comes to the interesting bits, when I start complaining about the data. Finally, I have a lot of people who are interested to listen about that. So the only 15 years available, and we had to predict 10 years ahead, right?
Could be worse.
Yeah, no.
Magic.
Yeah, so the data was sparse. So billion of categorical variables like asset model, and you have like, I don't know, 100 asset models, right, in each group. And look, then random variation, excess, excess zeros in the data. So of course, some assets or most decent assets do not get maintained, right? So lots of zeros in the data, and even worse with failures, because as you would expect, again, if they have decent assets, they do not often have a failure. So zeros. And small number of various failure rates. And I promised you, I was talking a bit earlier about this curve of age versus cost, remember? So it gets, it doesn't show the cursor. So anyway, in the beginning they expected it to be high and then go down, 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 and then go up. But if you look at the graph at the left, where you can see actual cost versus age, you can see that the story, like, it's not even close to that curve. No. So in other words, the data was clearly saying that there is a lot of things there that are responsible for asset maintenance and failure, other than age. Like, in fact, what we found, I will go into this later, but what we found is their data was not sufficient. So that huge amount of data that they gave us was not sufficient. The predictive potential of the data was not enough to explain what is really happening there. But before I go any further, I wanted to show you our methodology. So boring word, but basically what we did is, first of all, we did data audit, cleansing, and so on. Then we explored the predictive potential of the data. And this is, so in other words, we had to say to them, look, your data, like, we can confidently say that your data is not enough to explain what you want us to explain. And here is a figure. That's why. So and then they enriched our data. So the green square in the middle is data enrichment. So we added some data about climate. We also added some data about how far it was from the city center and from the nearest maintenance center, and a couple of other things. And then it worked. And then it worked, yes. And so after we enriched the data, and this was, you can see these arrows on the screen. So basically we did couple times making sure that our enrichment actually worked. And then we had all the data at hand. Speaking about various data science in here, right? So data science is firstly in the orange square, in the orange rectangle rather. So because this is where like all our estimation of predictive potential was in there. So everyone's favorite methods such as boosting, such as random forests, lasso, and we took a couple of others, just wanted to understand what's our predictive potential, and once we could tick it off, we then went to feature selection and modeling. We used again a number of just pretty standard data science techniques, and to make our regulator happy, or their regulator happy, generalized linear mixed models. Also, remember we didn't have enough data, so we had to kind of go into the panel data sort of layout. Anyway, and finally we expressed our models in the linear. That's your final step, just put everything into linear model. And in the business form, that was decision trees. And in the end, our resulting solution was a solution that maximized the predictive power derived from the data, enhanced linear models with data science, and delivered 18 models overall. So remember there are 6 groups of assets, and for each of them we had 3 models. So we had cost, we had failure, and had failure duration. So all these 18 models spread it out, and didn't spend too much time on that. And in the end, to enable efficient regulatory review, the modeling techniques used were a combination of classic techniques for longitudinal panel data and data science techniques. Now, I was told by the organizers of Meetup that I'm the second speaker, so I should be, brief. So they should, and has to be 20 minutes of the talk, and everything else will be in the question. So, I very welcome your questions. I can talk about this, like for hours. So, but I want to only talk about what people are interested in this case. Yes, please.
I'll just shout. So how did you actually optimize your linear models? What was your success criteria?
Linear models.
Yeah, your linear models.
So, look, linear models appeared in the picture quite late, right? Okay. So first we optimized everything else. So, and when we got to the point of generalized linear mixed model, which is, so we treat our data as longitudinal. So once we already were in the position that we selected all our features and put them in the linear model.
Could you stand microphone?
Oh, sorry. So when we got to the stage when we did all the feature selection, and so we basically had all the factors that actually were important, significant predictors. So then it was just standard statistical ways of fitting a generalized linear mixed model. How we refined it? Well, deviance, we looked at the deviance. We also looked at a couple of equivalents of R squared, just to make sure that we are not getting too far away. We also fitted a lasso regression, so where random effects are not very clearly present, like they were not that significant or small. We also ran a lasso regression in parallel, just to make sure that it is completely consistent with the GLM, generalized linear mixed models. Does it?
I've just gone completely. Am I allowed to ask questions? In a lot of this kind of this world, bathtub curves and Weibull distributions and survival curves, they're the norm. Everybody expects that. That's the usual way of doing things. How did you? I know you talked about R squared and all that kind of stuff. Did you find you had a lot of resistance in trying to push this? How did you get past let's say, people who had a very entrenched idea of how things work and then explain it to them. Can you talk us through that process a little bit?
Of course. Look, because we're not a large consultancy, we don't sort of like, we operate on the level that our stakeholders are comfortable with us and that they are completely confident in what we're doing. So it's an excellent question. It was not easy because basically like some of our team members, when we started talk about this project, said basically it's not possible to do because the data is there's too many problems and regulate and God knows what and linear and just too much, right? So the key was like our clients were engineers. So these are people who, just like accountants, they know everything, right?
I'm an engineer, so I agree.
Exactly. So they know, and that's why to get their respect and get their understanding was, an important thing to do. So first of all, we needed to build trust. So before we could work with them, we needed to build trust. First of all, we did a proper requirements collection just to make sure that they understand exactly what they want. Then we asked, okay, what have you done already? We tried these curves, these age things, and they didn't work. And then I said, okay, well, this is what we suggest to do. This is the industries where it worked. For example, it worked in banking, it worked in insurance, it worked in marketing, it worked in food industry, and I just gave them a presentation about that. And then said, and because of that, it also worked in transport, which they kind of can relate to. And I said that, why don't we do a proof of concept? And at the proof of concept stage, we will take a sample of your data, just one of your asset groups. We will understand what you want, and we'll show you the output, and we will walk you through it. You can ask us anything you like. Because we want you to be comfortable about what we are doing. And that's how it went. We had several meetings about this proof of concept, presented it several times, first at the immediate stakeholder level, then all the way, eventually presented it to the CEO of it's a large organization and very bureaucratic, so you had to kind of, before they were ready to part with their cash, they needed to. Yes, so that's, does it make sense?
I have a confession, I'm an engineer. So you've got my trust, but in terms of, we need objective measures, right? So how did your forecast actually compare against engineering judgment?
Against, sorry?
Engineering judgment.
Well, this is what we sat down with the main stakeholders and asked them what would be, when will you believe us? So this is like, I said, what do you need for you to believe the model results? And we said to them, we can show you this kind of model evaluation, this, and of course several of them, so you can compare. So basically you will see your data compared, actual data versus predicted, and it will be very close. And also then we will test it on a completely separate sample of data. So you will hold, randomly select sample, and then we'll test it on that. But also just to make your regulator happy, because remember, regulator is not a regulator basically hires a consultant who are econometricians who will just use linear methods and they don't understand what data science is at all. So we said that we will also make it easy to understand for econometricians will develop a linear model, and they can look at it, and will show them all the criteria, which is like they would expect to see a linear model to have, and that's your, you know, like I will not list now, but you know what I mean. So in the another thing that they asked us to do when the models were ready, they said, okay, so can we now test your model to the data that you have not seen? Because while we were doing it, there was another several months of new data on maintenance and failure and everything else. So they said, okay, can you test it? So we did that too. And then they said, okay. So that's how it was.
Validation is incredibly important.
I completely agree. In fact, look, I'd rather work with, like, it's easier for me to talk to an engineer because they understand mathematics.
Thank you, semantics.
But
Thank
for
you.
example, if you've got, say, like a 5% failure rate per year, does your model come out at like 2% or 10% or
Look.
in the ballpark?
Look, if we had, like, the average failure rate, you mean? Like average, like overall, right? I don't know, like isolators have 3% failure rate or something like that. Is that what you mean?
Yes, there are hundreds of different asset classes. It's
But I mean, when you say average rate of, average failure rate, how would you define average failure rate? Oh, sorry, no, I mean, like, do you mean that, do you mean that,
Hard.
do you mean that a certain group of assets should have this failure rate?
Sorry, I think it was probably an unreasonable question. It is averages of averages.
No, well, actually, I think if I understood you correctly, so basically, if a certain group of assets had overall expected a failure rate of 5%, then the model will also have exactly that, because remember, it's expected. Where could be, like, obviously we cannot be 100% accurate, and obviously on some of the assets, individual assets, we might under or over predict. But the main point of interest for the client was to find, among other things, was to find the assets that, like, say, top 10% assets that create cost or are likely to create cost in the next 10 years. And then they could kind of say to the regulator, listen, these ones, well, first of all, we want to perhaps even replace some of them, or at least repair them properly. Like, that's sort of reduce our kind of losses, in the sense that if something is too often requiring maintenance, perhaps we just need to do something more serious with it. So that's, anyway, so I'm probably going into too much depth, but basically, yes. But overall, of course, if it was 5% actual, it was definitely 5% overall predicted.
Excellent, thank you.
So, like you say, one of the, I'm over here, sorry, over to your right, over here, this way where we're waving, cool. Like you say, one of the challenges with this regulator is that they're basically enumerate, they don't know how addition works. And one of the patients with the energy space is that you're being employed by an energy company, but the person who's assessing the quality of your work is a regulator who you've never met, and they're basically employing someone who wasn't good enough to get the job that you got. So, at the end of all of that, how did you do? So with this prediction method, like it's more complex than what I've seen, which is, not to say much because it's mostly Excel-based in the rest of the industry. How did you go with the regulator? Did you get 90% through? Did you get 95% through the regulator? How did the regulator perceive this?
Look, I wasn't, they didn't tell me the details about how it went, but I know that the regulator didn't have too much questions, because everything was basically expressed as in the linear model, kind of in the report that they have received, and we were asked to write. Was basically, this is like, we used, data science methods to basically, in our language, for feature selection, and then here is your linear model. well, easy to, so we didn't have too many questions in terms of regulator. In fact, we had, like, before they even went there, they kind of played regulator with us several times, trying to ask various difficult questions. So that's what I know.
I've got a question around the data enrichment.
Yes,
you
yes.
mentioned original the data that you had
Yeah.
was inadequate, essentially.
Yep, yep.
Actually,
Not inadequate, just not sufficient. Yeah.
yeah, you didn't have the predictive power, but then you added some. I think you mentioned environmental data. I don't know.
Yes, yes.
How do you determine what kind of additional data to bring in?
This is, but basically we asked our client, we said, you are the subject matter experts. It seems that the data that you gave us doesn't completely answer our question. What else do you think might affect the outcome? And they said, oh, what about proximity to the shore? What about this and that? What about that some of these assets are sitting, for example, in the desert and it's cold, at night and very hot in there, things like that. So they basically said, well, this basically we had a workshop or couple, and they told us, and then we had another workshop and said, all right, so you gave us this list, which ones is easy for you to get hold on, and basically they said, oh, we have better, already in the organization. We have the distances from maintenance centers to assets, so they just didn't think about it. But when they understood that overall our first model that was done before data enrichment kind of made sense to them, then they said, oh, okay, let's see what else. So that's and that was the next step that like suddenly we didn't have the what you call inadequacy of data. Yeah.
Just a follow-up on that. And so you mentioned that there's a lot of unclean and missing data. So for that, did you have to say impute anything or just ignore those records? How do you deal with that?
Well, our problem wasn't that it was missing, but that it was noisy. For example, when database people were combining several files from several sources, they could have, So we did, so this was the problem. There wasn't much missing data as such. But to make sure that our data is clean, we did data audit. So basically, we just made sure that, like, first of all, we asked them for business rules, and they said to us that, for example, if a sort of failure is this long, it's not normal. Things like that. So rule of thumb. So we checked for all that, and also we checked that all the records kind of. Just, standard data auditing, just all the records made sense, there wasn't anything strange, like there was no assets with the age of 1,000. So we did find a couple of the things.
And you also mentioned that lots of zeros in the data. So
yes.
How do you try to make sense of the zeros, or like any statistical from zeros?
Yeah.
Or?
Yes, so one of the, so when we had this, with some of the assets, others were okay, but some assets practically don't fail, very, very infrequently, and which is good, of course. So with zeros, there are just special modeling techniques that are developed to deal with data with excess zeros, and we just tried several of those. So, they worked. Again, that's most of them were, we were lucky, most of them are linear, so that was good too.
I have a question over here. You described very well the journey taken to bring the client up to speed to gain trust, and the room's been a little bit critical of the simplistic model the regulator required. What will be needed to bring the regulator on board so that more complex models could be considered?
the regulator. Well, it's well, like I can't tell you what, but if, meaning that if the regulator came to us and said, look, we really would like to understand what can be done, what the organization could have done. If they were open to it, if they basically express something like this, then it would be like with any other client. So basically, I suppose that Eugene's data literacy course would be used. But basically, yes, just a bit of education, just saying, look, what we did with our stakeholders in the beginning. We said, this is what's happening in the world, in the industry, this is some mainstream methods, they work, and just make them comfortable as, like, it's not difficult to explain what a data science model does. And you can always say, look, if you want to go into the statistics of it, here's 20 references in short.
Last question from Michael. Let's finish on a high note.
I wasn't going to ask anything like that. Well, I had two questions, if that's okay. So, one is really how much time, what you spent the most time doing out of all of those things, really. Because it was interesting, because you at some point you kind of alluded to data science being the XG boost and whatever, but I kind of think of data science as being the whole process, but then I looked at this again and saw that it is said that. And the other thing is, on the talk of kind of models, linear models that you've kind of worked with, I just wondered if you had considered other approaches for the regulator, such as interpretive modeling, and if the problem with the models is more than just that, they don't have coefficients, so they can't be proved to be linear. Like, is it like in terms of the way those models are, like, are they sort of random forests or something which you can't actually interpret them, and then could you bring things like Lime in to do kind of better interpretive modeling of those models? How do you consider that? So.
Understood. Okay, so first question is where we spent the most time, correct? Yeah. It was it was data audit, checks and cleansing.
Yeah. It always is, yeah.
No surprises there.
Yeah.
Secondly, the question was, if I understood correctly, was why didn't we go the interpretive model way and just gave the regulator something that they would hopefully understand? The answer is the regulator. We were told that the regulator will hire a consultant to check our work, and the consultant will probably be a econometrician, and the econometrician will probably expect a linear model.
Yeah.
So
oh, that's right. Okay. Yeah.
Otherwise we wouldn't. Otherwise we would just do a decision tree, for the client and stop at that.
Yeah.
Yes.
Cool. Oh, thank you. That makes sense. Thank you.
Well, can you and for all the econometricians out there, I think you guys are great. I actually think that some of the things econometricians learn, particularly causal impact analysis, is probably the most hardcore data science you can do. So for the causal impact machine learning savvy econometricians out there, you guys have my full respect. And there's at least one in the audience. Where are you, Yuri? There he is. There's probably a few more. So can you please all, well, you just did. Let's thank Inna again, she deserves it. And now comes the section that we usually call announcements, but today is going to be called the Parade of the Gregs. There's usually more than one. So Greg, we'll start with the usual Greg from N-World, and followed by the Greg from CDA. So over to Greg Fell from N-World.
Thank you. I don't need a mic. Thank you, Michael. Thank you, Inna. It was fantastic. Michael, I know Data Republic really well. Recruited for them in the past, which is great. So I'm a data science recruiter. I think a lot of you know me from being here for way too long. yeah, look, it really just, I'm here as a source for you guys to know what's going on in the market, know what roles are going on out there. I'm recruiting for machine learning, modelers, data scientists. I've also got a plethora of really strong candidates. So if anyone's looking to build their teams, please reach out to me. There's some really good candidates out there, definitely at all levels. But I hope you enjoyed tonight.
Do we have any more Gregs? Greg from CDA. What's your last name, Greg? Paul. Greg Paul. Is that a...
So Greg Paul. This has been a very, fantastic evening. Hi everyone, I work for CBA. I work in the data science teams. We do some pretty interesting work around here, and like end up working with a lot of really cool cutting edge tech. If you want to know what it's like to work here, speak to myself or Perry, guy wearing a tablecloth. Thank you, Jose, for that joke. I had that same joke. Just speak to us after this.
You know I love your jokes.
Speak to us after
Kevin's
this.
here too. Kevin from recruitment. So, like technical questions about recruitment, go to Kevin.
Exactly. All right, thank you.
Oh, thank you.